Hello, teacher. I am Jose Moreno, and this is my presentation on switching power supplies, specifically the step up or so-called boost converter. It is a pretty basic converter, and its use is so widespread across the medium as long as you need to elevate the voltage. In contrast to the buck, which lowers the voltage, this one will do exactly the opposite, which is to elevate the voltage in comparison to the entry voltage. So we will take a look at how the circuit works and how to build it with a few components and an Arduino to create the pulses and the feedback. So if you have a circuit that works at a certain value, say 5 volts, and you have a different part of that circuit that requires a higher voltage, one way to get that is to use a boost converter. We apply a voltage to the input and get a higher value at the output. The requirements of this circuit are that even if you change the input value or apply a different load to the output, we will have the same voltage at the output. So we surely need feedback, and we will see how to do this later. So how does the circuit works? As always, we'll start just with a power supply, let's say 5 volts, and a load of 100 ohms. If I only have the 5-volt power supply and want to apply 10 volts to this load, how could I do that? For that, once again, we will use the magic of an inductor. So we add this component to the circuit. The magic of the inductor works like this. The inductor does not like changes in the current, just like the capacitor doesn't like changes in the voltage. If we create a current flow through this inductor, in this case of 50 milliamps, and then stop that current, the inductor will store whatever energy it has, and it'll do whatever it has to maintain the same amount of current. As current is voltage divided by resistance, and the resistance is given by the material of the inductor and cannot be changed, the only thing that has to change is the voltage. So the current becomes smaller. To maintain it the same, we have to increase the voltage. And that's how we boost the value. Apply a voltage to a coil and it will create a magnetic field around it. When you stop applying the voltage, the magnetic field collapses, creating a large voltage spike. So our circuit will have a button. In this case, it will be a MOSFET that will open and close the circuit like a switch, switching between the output of the coil and the ground. Given that the output voltage will be higher than the input at certain times, we do not want a current flow backwards, and that's why we add a diode. But we also want a stable voltage at the output, not just the spikes that the coil creates. And to store the voltage and do that, we add a capacitor. So basically our circuit is ready. All we have to do is turn on and off the switch, creating the magnetic field and then collapsing it, increasing the voltage. When the MOSFET is on, like in the picture at your left, the current will flow in this way. When we disable the MOSFET, the coil wants to maintain that value, and that's why it will push the current through the diode, charging the output. If we do that fast enough, we could have the output stable higher than the input. To turn on and off the MOSFET, we can use an Arduino to create a PNW signal to apply to the gate. We can then use the MOSFET for the switch, an inductor, a diode, and a capacitor. We will connect a potentiometer to the input in the Arduino logic to be able to adjust the output value. Then in the code of the Arduino, we will read the value of this potentiometer and we will change the PNW signal applied depending on this potentiometer to the gate of the MOSFET. So the circuit works. But what is missing? Well, let's see. What happens if I change the load at the output? If I remove the load resistor, then the output voltage changes. And we don't want that, of course. Of course, with different load values, the current will be not the same. And at the same time, the charging and discharging time of the output capacitor will also be different. So we should inform the Arduino that the load has changed. And then the Arduino should also change the PNW value to be able to maintain the same output. This process is called feedback. So what we have to do is add a voltage divider at the output and make sure that in all cases, the voltage of this divider will be less than 5 volts. Since that is the maximum analog input voltage for the Arduino. So that covers its functionality. We can go into some of its applications. So between the characteristics of this converter is that it has a voltage increase, it has efficiency, it helps regulate in voltage regulation, it can be used in synchronous configurations and battery charge applications. Thank you.